We're going to start with a quick review of yesterday's skill. Let's start first with a little bit of vocabulary that we talked about. Yesterday we talked about rows and columns. So rows go side to side, and columns are straight up and down. So we could say horizontally for side to side for rows, and vertically for up and down for columns. So let's start by first counting rows and columns. So we have 1, 2, 3, 4 rows, and 1, 2, 3, 4 columns. Okay, so now I'm going to assign my fractions a color here. So I see three. There was a small tag on Tanner's Chromebook that was 3/4 of an inch wide and 2/4 of an inch long. What was the area of the small tag? So I already counted my rows and columns, and I have 4 of each. So these fractions are going to work for this model. So I'm going to label 3 out of 4 in blue, and that's how I'm going to represent my rows for this 3 out of 4, 3/4 of an inch. And I'm going to use, let's say, red to represent my columns, which was 2/4 of an inch, or 2 out of 4 columns. So I'm going to write that down here. We're showing area. All right, so let's go ahead and do some shading. Since 2 out of 4 is going to be my columns, and I already have red, then I'm going to go ahead and shade 2 out of 4 columns. Now I'm going to go grab my blue or turquoise here, and I've identified that there are 4 rows, and my denominator is 4, so I don't have to make any changes with the fraction. So I can just go ahead and shade 3 out of 4 rows. Now we'll grab black, and I'm going to make a fraction for this product. So the denominator is always how many parts make up the whole. So we've talked a lot about arrays. You've been talking about arrays since 2nd grade. We know that this is a 4 by 4 grid. So we could count each separate square in the grid, or because we know this is 4 by 4, we can easily multiply 4 times 4, and the product is 16. So 16 squares make up the whole grid. Now let's count to get our product, how many pieces we have. We are going to count the overlapping squares in this grid. Overlapping, we talked about that vocabulary word yesterday. That means something laying on top of something else. In this case, we have turquoise, or this blue color, on top of red. So that is what's overlapping. That's what's going to represent our product here. So I'm going to circle all of the squares that have that overlapping shading. So let's count those up to get our fraction here. We have 1, 2, 3, 4, 5, 6. So 6 out of 16 squares had overlapping shading, so our product is 6/16. Now last, we're going to ask ourselves, can this be simplified? We do that by dividing by 2, 3, 5, or 7. Down here in 5th grade, you'll use your greatest common factor when you get up to middle school next year. So we'll start here with 2. 6 divided by 2 is 3. And 16 divided by 2 is 8. So remember, we divide until we can't divide anymore. So can I divide both numerator and denominator by 2? The answer is no. Can I divide both numerator and denominator by 3? The answer is no. 5 and 7 become too large because they're bigger than this denominator, so they're out as well. So what is the area of the small tag? The area is 3/8 of an inch. Okay, let's take a look at the next problem. One more example. Before you get started, Keelan has little trading cards that he likes to trade with friends. Each card is 1/2 inch wide and 6/12 inch tall. What is the area of the trading card? Okay, so we have a job to do first here because if we look, we have the same size grid, which we know on the last problem was 4 by 4. Neither of our fractions here have 4 as the denominator. So that means we're going to need to find equivalent fractions for both 1/2 and 6/12 with the denominator of 4. So I'm going to go ahead and set this up and ask myself some simple questions to get that common denominator here. Okay, so remember, whatever we do to the denominator, we must do to the numerator. So how many times larger do I need to make 2 to be 4? And that answer is multiply it by 2. 2 times 2 is 4. So whatever I do to the denominator, I must do to the numerator. So an equivalent fraction for 1/2 with a denominator of 4 is 2/4. Here I'm going to work kind of backwards. How many times smaller am I going to have to make this 12 to be equivalent here? And the answer is, or I could work the other way, 4. How many times larger am I going to make this 4? The answer is 3 times larger or 3 times smaller. So here I'm going to have to do the same thing, divide it by 3, and the answer is 2. So now I have 2 equivalent fractions, 2/4 and 2/4, and I'm going to come down here and now I can do that shading. So first thing, let's grab our colors. We're going to represent our rows with 2 out of 4 in red, and I'm going to go ahead and shade 2 out of 4 rows. Now I'm going to represent my columns 2 out of 4 with that turquoise color, and now I'm going to shade 2 columns. Let's shade over here this time. 2 out of 4. Last step, we are going to grab our other color and we're going to identify which of these has overlapping shading. That means red and turquoise, or red and blue. And the answer is 4. 4 out of how many? 4 out of how many would make the whole? That is the denominator. So again, we had a 4 by 4 grid here. So we know 4 by 4 really means 4 times 4. So we have 4/16. And last, our simplifying strategy of dividing by 2, 3, 5, or 7 until we can't divide anymore. Let's take a look. Can I divide? These are both even numbers, so that tells me I'm going to be able to divide by 2 right away. So 4 divided by 2 is 2, and 16 divided by 2 is 8. Looking at it, I can still, both even numbers again, I can still divide again by 2. So I'm going to take another step to simplify or get it in lowest terms. 2 divided by 2 is 1, and 8 divided by 2 is 4. I now have a 1 in my fraction, so that means I cannot divide that prime number anymore. So 1/4 is the product of 1/2 times 6/12.